Derivatives of tangent, cotangent, secant, and cosecant. Okay. When you guys get your study guide, the last page, there's a lot of blank space. So one of my recommendations is to write down all the derivative rules you guys have learned so far. So we already know these two, right? We're going to write them down again right now. But you guys also have learned the power rule, right? And you guys have learned the derivative of e to the x. You guys have learned the derivative of natural log of x. You guys have learned the derivatives of a to the x and log base a of x, okay? So what is the derivative of sine? Cosine. What's the derivative of cosine? Okay. In the video, I'm not going to show it, but after the video, if you guys are curious, I'll show you guys where these two come from. Okay. What's the derivative of tangent, you may ask? Well, obviously, secant squared x. Okay. Now, sine and cosine, those are kind of like opposites, right? If you guys can think about it, don't think it that way, but that's how I thought about it in my brain. Tangent is secant. Do you guys agree that tangent and cotangent are reciprocals? So what do you guys think that the derivative of this is? It's like whose buddy is secant that we've talked about? Cosecant. So it's going to be negative cosecant squared x. The derivative of secant is weird. It's secant of x times tangent of x. Which means the derivative of cosecant, so basically try to like apply the same logic. What do you guys think the derivative of cosecant would be? Cosecant of x times cotangent of x. Now, something that is cool is that, do you guys see how this is cosine? This is cotangent, and this is cosecant. Do you guys see how the derivatives of these are negative? So is this one. If the function is co-something, the derivative is negative. So cotangent, cosine, cosecant, all those derivatives are negative. Okay? Now, I don't know how to say it other than the fact that you guys just need to memorize these. All 6 of these you guys need to know. And then next semester, when you guys learn about integration and you're going backwards, you'll have to really know them because you have to know whose derivative is that, and you have to just go backwards. All right, so what you guys are going to struggle on is memorizing it, knowing your unit circle. If I ask you guys to find like tangent lines at x equals pi over 3, you need to know your unit circle. Simplifying trig expressions, we're going to do something like that in the first example. And then how do I do a trig reciprocal in a calculator? So if I see a lot of you guys don't have your calculators out, that's okay. Take out your calculators because we're going to use it for one of the problems. All right, so example 1. Find the derivative of y equals sine of x tangent of x. Okay. So guys, what is happening operational wise between the two functions? Multiplication. Wednesday, you guys learned the product rule. So remember we talked about, I could call this like my f function and I call this my g function. So remember, just off to the side, I'm going to say dy dx, remember, is f prime g plus fg prime. So I showed you guys one of the things you guys could do is kind of like organize your work. You could figure out what f prime is, what g is, what f is, what g prime is, and then plug it into the formula. Or you could just do it as you go. It's up to you. So what's the correct notation for the derivative of y? Y prime or dy dx. I want you guys to be comfortable with this one because in unit 3, we're going to be using this a lot. So dy dx is equal to f prime. What's the derivative of sine? Cosine. So it'd be cosine x times g, tangent of x, plus f times the derivative of tangent, which you guys just learned is secant squared x. Okay. On a test, technically this is okay. However, if it was a multiple choice AP question, this would not be the correct answer. Because something you guys learned in Math 3 or in pre-calc was tangent is sine over cosine. So I could rewrite this as cosine of x times sine of x over cosine of x plus, what's the reciprocal of secant? Cosine. So there's sine and then 1 over cosine squared. Do you guys agree that's what secant would be? There's no really like nicer way to write that, so I'm just going to leave it like sine x secant squared x. Right here, my cosines cancel. So I'm left with sine of x plus sine of x secant squared x. And you guys remember me telling you guys that sometimes you can factor out a GCF. What's the GCF? What? Sine of x. So sine of x times what? 1 plus secant squared x. Now in AP Calc AB, possibly in BC, do you guys remember there was an identity you guys learned? 1 plus tangent squared is equal to secant squared. So this one actually, because of the way the signs work, you can't rewrite it that way. So in this case, we could stop. Do you guys remember that in pre-calc, 1 plus tangent squared equals secant squared? Do you remember learning something like that?
Yeah.
So the way this works out with the signs, you can't rewrite it this way. Because the 1 and the secant, they're not the correct sign if you move things around. 1 minus secant squared is tangent squared, not plus. Yeah. So we lucked out here. All right. You guys ready for another one? Okay. This one looks easy, but it's really annoying. Find f prime of pi over 6 if f of x is equal to x over secant of x. Okay. So the first thing you need to do is I need to take the derivative. I have two functions divided by each other, so I need to use which rule? Quotient rule. So quotient rule says you guys remember what it is? Low D high minus high D low over the square of what's below. Low D high minus high D low over the square of what's below. So low is secant of x. D high, what's the derivative of x? 1. So do you guys agree this would be secant x times 1? Do I need to write that? No, because anything times 1, does it change? No. You guys everyone okay with that? Minus. High, D low. What's the derivative of secant? Secant x, tangent of x, all over the square of what's below. All right. So do you guys agree this is x secant of x? So what I could do is, do you guys see how there's a secant x here and a secant x here? I could factor that out because you guys see how I have secants on the bottom. That's going to make it my life easier because stuff will cancel. So I'm going to factor out a secant of x. So secant of x times 1 minus x tangent of x all over secant squared x. And then one of these secants will cancel with one of these secants. So I'm left with 1 minus x tangent of x all over secant of x. Okay, is everybody cool with that? All right, that's a derivative. Now we have to plug in pi over 6. So f prime, where does this come from? Right here? Where did what? It's right here. Because this is x secant of x, right? And I factor out the secant x, so I'm left with x tangent of x. Okay. So f prime of pi over 6 is going to be 1 minus pi over 6 times the tangent of pi over 6 all over the secant of pi over 6. All right. What's the tangent of pi over 6? Square root 3 over 2, 3, 5, 7. Square root 3 over 3. Okay. The secant of pi over 6. Secant is a reciprocal of cosine. What's the cosine of pi over 6? Square root 3 over 2. So the secant of pi over 6 would be the reciprocal, so it's going to be 2 over square root 3. Now, what I could do is take the top and multiply by the reciprocal of the bottom. So this is going to become 1 minus, if I simplify this, I'm going to get root 3 pi. Actually, no, I don't want to do that. No, yeah, I can. Over 18 times the reciprocal of the bottom, so square root 3 over 2. All right. You guys ready for some weird math? This one's weird. This one's easy. Root 3 over 2 times 1. Hey, that's root 3 over 2. Minus. Okay, what is square root 3 times square root 3? 3. So this is going to be 3 pi over 18 times 2 is 36. Does 3 over 36 simplify? Yes. 1 over 12. So this is going to be root 3 over 2 minus pi over 12. Okay, I just want to make sure, because I'm not giving you guys a problem like this in your notes, because we've done it already in class. When I take the derivative and plug in the x value, what did that find? I heard it.
Slope.
The slope. So this would be your m. If I asked you guys to write a tangent line, this would be your m. Both these numbers together would be your m. Okay? To find your y, do you guys agree I could have taken pi over 6 and plugged it in at the beginning? That'd be my y1, and then I could write my tangent line. Okay? I didn't ask you guys on your quiz, but do you guys remember how to find a normal line? Normal is just perpendicular, so take your slope and flip it upside down. So I wouldn't ask you guys something like this on your test, because that'd be dumb, but this, you'd have to do the reciprocal of that technically. All right. Calculator problem. All right, this one's a really important example, even though it doesn't look that serious. Estimate with a calculator. The derivative of g of x is equal to cosecant squared of 4x at x equals 2. Okay, so before you guys do anything, cosecant is a reciprocal of sine. So this is the same thing as 1 over sine squared of 4x, right? Now, your calculator, you cannot type it in exactly this way. So understand, guys, that like if it, whenever it's like sine squared x, that really means sine of x squared. Does that make sense? Because we write the power before the argument when we talk about trig. The power usually goes in between. Do you guys know what I'm talking about? So what this really means is 1 over the sine of 4x, all of that squared. That's how you would type it in to your calculator. Which is the shortcut to do a derivative of my calculator? Math 8, thank you. Nice. You guys should get that. So 1.2019, so the three places, 1.202. Okay. Questions? You guys look super unimpressed from that problem. It's Friday? We can't be excited on Fridays? No? You want to go home? I know. I have a... Oh, yeah, you are going to get home. I have a video game waiting for me at home. Okay. Last problem. You have trauma? Head trauma? What the heck? Don't say that. Okay. This is asking me, this formula means the derivative, right? What is your f of x in this problem? Cotangent of x, right? What's your x value? Pi over 4. Okay, so this is asking me to take the derivative of my function at pi over 4. So I need to figure out first, what is the derivative of cotangent? So f prime of x is equal to, according to our notes, what is the derivative of cotangent? Negative cosecant squared x. Good. Okay, so that means f prime of pi over 4 would be negative cosecant of pi over 4 squared. Okay, cosecant is a reciprocal of sine. So this is the same thing as, if I write it off to the side, 1 over the sine of pi over 4 squared. What is the sine of pi over 4? Square root 2 over 2. So the square root 2 over 2, if I do the reciprocal of that, do you guys agree that would be 2 over root 2? Right? I'm going to square that. What's 2 squared? 4. What's root 2 squared? 2. So this is just 2. So all of this right here is just 2, but I need to make it negative. So this is going to be negative 2. Okay, I want to say that again because I feel like I lost some of you guys. Reciprocal of cosecant is sine, correct? The sine of pi over 4 is root 2 over 2, but because I'm doing cosecant, I just did the reciprocal. And now I'm squaring it. So if I square it, you guys agree I could rationalize and all that fun stuff, but I don't need to do it because look what happened. It ended up being nice. Okay? And then I get negative 2.